we want to order it by slope from low to high. What do? All we have to do is this. And remember what I said about attaching it. We are able to reference the names of the variables directly only because we attached it. If you don't issue that command, attach worms up front, this is not going to work. None of these will work. Okay, so if we do this, note what happens. It returns a vector of the indexes. But if we apply that to sort all the rows in the data frame, that we get what we want. We get the entire data frame sorted from low to high based on slope. And we can tell that it worked and we didn't mix everything up because here are the row numbers. But when this happens, when we do this, the way order works, it ignores ties, or said a different way, when two values are the same, whichever one it encounters first gets listed first. So for this group of records here, there's really no change at all in the sorting. As it encountered the zeros, it grabbed the whole record and didn't bother changing it. So these are always going to be in the same sequence, as will the twos, as will any ties. But you can do a two-order sort or a three-order sort. You can also reverse it. The REV function is reverse, and that just simply will sort. It reverses the default sorting order from low to high to low. So, and it's waiting for me to return another parentheses. So if we do that what that achieves in this context is it will return the data frame with sorted by slope backwards. Or you can do, as I mentioned a second ago, you can do two order, just simply because we attached it. This vegetation would be first, worm density second. So if we do that, now we'll take a look. So here's vegetation. Note there's a lot of common values. For example, these are all the same, grassland. And now if we go over here and look, though, we see that within grassland, instead of being in the same order they were in before, it has performed the two-order sort and sorted by worm density low to high as the second sort. Now, if you go back and look at, if we query, vegetation is a factor here. These are factors. This is not a character or a string type. And in fact, whenever you create a data frame, if one of your vectors is characters, text, string, it will change it to a factor. Data frames cannot handle characters except under special circumstances. It will change it to a factor, and that can be you need to be aware of that because that can be confusing sometimes. Okay, what about a three-order sort? Can you do that? Why would you want to do that? Well, note that here with grassland, when we did the two-order sort, when there were ties with the second one, same thing. It doesn't rearrange anything for those. It just takes them in the order they were originally in. So you can do a three-order or four-order, as many as you want. So if we do a three-order sort, then there's the grasslands. Here are all the twos for density, but now they are changed by this one. So you can rearrange your data set any way you want, like that. If you're rearranging it by rows, and that's generally what people are doing. Generally, sorting is usually done by rows. It's uncommon but not unheard of to want to sort the columns, but you might. And you do different things generally to the rows that you do to the columns because of the nature of what's represented in each. The rows are observations. For example, you might want to exclude rows that have missing data. It'd be unusual to want to exclude columns that have missing data, but you might want to throw out the observations that have missing data. Or you might want to select only those rows that have a certain value in one variable. You wouldn't want to do that to a column. So the nature of the activities or tasks that you perform on them are going to be different, regardless of whether you're using R or SAS or SPSS. Can you rearrange the columns? Well, yes, you can. Okay, anything you put here in the column vector, if it evaluates to a number, if you want to rearrange the columns, you just create a vector, and this will cause the output to put the fourth column and then the seventh column and then the third column, and that's all. We'll select those 4 columns and we'll change the order that they were in the original data set. And again, we're not assigning these to variables, but you could. You could just simply couple any one of these expressions with an assignment operator and name a new variable, and then you have that preserved in your session, that subset. So, okay, so that's pretty clear. Now, you can also have expressions inside the indexing operator that evaluate to true and false. And remember, we mentioned early on that in R, the equal sign is not equal. The equal sign is actually an assignment operator. So if I do something like this, X, let's create a different one, W equals, and we'll use a sequence operator to make it quick, this, and then note W has been created as a variable, and if I say what is W, we've created a vector. Now, because the equal sign, so that's what the equal sign does. If you want equality, it's just like Java. If you want equality, you cannot use an equal sign. And I always forget to do this. If you're testing, this is a condition. What you're doing here, you're not assigning anything, you're testing a condition. Is the value of the damp variable true? Let's see what happens when we get that. Are we going to get numbers? No. We get back a vector that runs down the column of damp, and it checks the value of each cell in the damp vector, in the damp column, to see if it's true or not. And if it's true, it returns true. If it's damp, if it's damp, it returns a true. If it's anything other than damp, it returns a false. So now we have the expression, which is just testing a condition, in the rows part of the subscript, a vector of trues and falses. Well, what happens when we execute that against the entire set? It just pulls out the records for which damp is true. Okay, so you can select. You can put any sort of condition in there. Any sort of complex condition. So here we're saying I want the worm densities, I want the records that have worm density that's greater than the median of worm density. And I only want the records for which soil pH is less than 5.2. But I want all of the columns. So remember, again, this is just, let's see what this does. This doesn't return numbers. This returns trues and falses. And then when we apply that in the row designator, it only returns the records that are true. See Linda's comment. Double quotes around the column name slope. Interesting. Did you attach it? Okay, well, I believe you. Something to note. Okay, so what else can we do? Well, here we're introducing another function, sapply, and sapply is one of those functions. It's a vectorized function that will take any vector as an input, whatever the first argument is. It's looking for a vector in the first argument, and it will apply the function that is the second argument to that vector. So what happens when we do this? When we say sapply, it will let's go to the actually this is the data set, so let me backtrack here. It is taking this object and it is going to be applying this function to each column in this object. So let's do this. So we say, let's just do this part. Again, if you ever get confused, and I get confused all the time, you just start from the inside out. So we do this, and it is going in there and testing the type in each column and returning a true or false. So when we apply it to the entire data set, it will return all the records, but only the columns that are numeric. And note the function isNumeric is testing. It returns a true or false. IsNumeric, isFactor, isCharacter, isVector. They test the argument, and if it is that, it returns a true, otherwise a false. Okay, so we could do the same thing here. Here we're applying isFactor using sapply. Sapply is one of the apply family of functions that very useful. We won't get into it. We don't have time in this 5-day class. We do it in the boot camp. The apply family functions are great. They're all vectorized. They remember we said we have structures that have different characteristics and different dimensions, and so we can't just routinely run functions like mean and standard deviation. The apply family of function will do this for you. So here, this will just simply return all of the columns that are factors, and so that's what you get. Now, data frames do coerce character vectors. So if we did this, if we said just return the columns that are characters, you get nothing. It does return an object. It doesn't fail, but it's empty. 0 columns, 20 rows. Even if the original vector was a character, when you put it into a data frame, it changes it. Now here's another interesting operator, which in this context, remember I said some of the mathematical operators have two meanings. When you use the hyphen, which is what it is, also known as a minus sign, as an operator within a subscript, it doesn't subtract anything. What it does, it means include everything else. It doesn't take anything out at all, even though that's what it looks like what it's doing. What it's actually doing is ignoring rows 6 through 15 and including all of the rest. So if we use it in this context here, it just simply returns all the other rows except for that.